All right, the last example I'm going to work through is it's pretty complicated, and but it illustrates a particular procedure. It's kind of a rare bird. Usually, now I've erased the procedure I had here because I just need more space. But remember, typically you start with the more complicated side. The problem is this thing is about equally complicated on both sides. And so it might be difficult to start with this and manipulate to get to here, or vice versa. So, if both sides of the equation are about the same complexity, this is a technique that can help. What you may do is start with the left-hand side and completely simplify it. Then go back, start with the right-hand side, completely simplify it. If you get to the same final result in both sides, then that's valid. What you may not do is start from the given equation. You must start with the left-hand side, write it down, and then see what it's equal to. Then you must go back to scratch. Start with the right-hand side, write it down, and then find what it's equal to. What you may not do is continue this equality all the way down. You may not include the statement of what you're trying to accomplish as a line in your verification. You may not do that. That is not correct. It is not logical. It's not accurate. So what you may do is this. You may work both sides and try to match them at the bottom. That's what I'm going to do. I'm going to work left-hand side what is this equal to? I'm going to bring this down over here on this side. Oh, I left something out here. This is 1 plus. Well, some algebra says I can distribute this. So distribute the algebra. See what we generate. If you do that, what do we get? We distribute here, we get tangent squared plus tangent times cotangent. Tangent squared times, or plus, tangent squared times cotangent squared. All right? Well, what's this? This is tangent squared. Nothing happening here. But look what we have here. We know our reciprocal identities. You don't need to change the sines and cosines. Just change everything to tangent. This is tangent squared. This is times cotangent is 1 over tangent squared. Keep simplifying. The algebra says you can cancel these. So this is tangent squared plus 1. And what is tangent squared plus 1? That's Pythagoras. Pythagoras says this is secant squared of x. That's probably about as simplified as we're going to get it. So let's leave that here. Now, what I have students do, and if you want to get credit out of me, this is what you do. You draw a hard line. This is the left-hand side, which is handled completely separately from the right-hand side. Right-hand side, write it down. Cosine of x over cosine of x minus cosine times sine squared. Well, what can that? Well, you can't cancel here. You must factor before you cancel. The rule is you must factor before you cancel. You must factor before you cancel. So what you may do is out of this denominator do some algebra. Factor out the cosine first, leaving behind 1 minus sine squared. The numerator still has cosine. And now that we've factored out the cosine, yes, you may cancel these. Reduce is the technical word. When everything reduces from the numerator, we leave a 1. This is 1 over 1 minus sine squared. But what is 1 minus sine squared? Well, we know Pythagoras. One of the alternate forms for the Pythagoras identity is that 1 minus sine squared is equal to cosine squared. So this is 1 over cosine squared of x. But what is 1 over cosine squared of x? Well, we know our reciprocal identities. This illustrates why these identities must be part of your mental furniture. You must have these hanging around your mind so that when you need, you can pick it up. This is Pythagoras, and this is the reciprocal. This is secant squared. And A is equal to B. C is also equal to B. So A and C must be equal. This mess is equal to secant squared. That mess is equal to secant squared. Therefore, these two messes must equal each other. This, assuming these steps are reversible, and they are, this is a valid verification of this identity. If both sides are very complicated, this might be a better technique to simplify the left, simplify the right. It must be done completely separately, this side without reference to this side and vice versa. And if you meet in the middle, that is a valid verification.